Hi everybody, welcome back to class. We're going to be continuing our lesson with the scientific method and scientific inquiry by picking up where we left off last time, and we're now on test your hypothesis. Previously we stopped at forming your hypothesis. We're going to continue with testing your hypothesis. But before I begin, please make sure as you're watching these videos that you are recording the pieces in your notes. I have sent you a copy of guided notes that are missing pieces from the video or from the notes that I'm showing you here in the video. You must record those in your own notes. I will not be giving you a completed copy of the notes. So thank you. Let's begin. So as we said, we're picking up with testing our hypothesis. After you have formed your hypothesis, you have to test it using something called a scientific investigation. Now, the technical definition of a scientific investigation is the procedure by which scientists, and I have a typo, so we'll just take that out. The procedure by which scientists seek answers to their questions and test the validity of their hypothesis. They're using some way to figure out if they are correct or not based on their hypothesis. And there were three broad types of scientific investigations. The first one we're looking at here is an observation. An observation is information gathered with your five senses: sight, hearing, touch, taste, smell. For example, if we go back to the question of what happens when you tip over a cup of water, you could use an observation to test your hypothesis of whatever you come up with would happen. You can watch one person tip over multiple cups of water. You could watch multiple people tip over a whole bunch of different cups of water. But you're going to be using an observation. You're using your sense of sight to figure out if your hypothesis is correct or not. You could use sight if you're going out into the woods and you're trying to figure out where are the deer? Where am I going to find the biggest buck this year? And you're trying to test your hypothesis. You came up with a hypothesis saying, I'm going to find deer in this area. And you walk out into the woods and you look for different signs of them all over the place. That would be an observation. You also could use a controlled experiment as a type of scientific investigation. And controlled experiments are an experiment in which only one factor or variable is being tested at a time. This is what you will mostly use in class. This is what you see a lot of the times in a lot of labs. And at least in this class, you're going to be using controlled experiments a good bit of the time. The third kind of scientific investigation is called a model. Now, a model is a representation of something too big, too small, or too expensive that can be used to show or explain how it functions. One example of a model is a physical model, or let's say a globe. The globe is a model of the Earth, and the Earth is just way too big for you to try to study, all at once at least. So what scientists have done is taken the Earth and shrunk it down to scale and made it into a globe. And now you can study geography based off that globe because everything is now to scale of what it would be on the Earth if it was full size. Another physical model could be the model of an atom. And if you come into my class, you can see different models of the atom that are in my room. Atoms are too small for us to normally see. You can't see them with the naked eye. And even with microscopes, even though they're getting more powerful, you still can't really get clear pictures of atoms to study. But they build models of them so that you can see the different pieces and you can study atoms. The other type of model would be a computer model or a computer simulation. If you like to play video games, you've probably seen computer simulations a couple times. You might even play computer simulations. Let's say flight simulators. It's too expensive to give somebody who's brand new to flying an airplane. So they build flight simulators so they can go out there and test it. It's a model of an airplane. All the controls are the same, but it's not going to, one, injure somebody or multiple people if they crash the plane, and it's not going to cost them a bunch of money because it's just a computer program. The third type, it got cut off here, but the third type, of model is a mathematical model. Now, mathematical models are basically equations. So when you're looking at mathematical models, you're looking at equations, long, complex equations. And they also use this to study things like atoms because they're so small, but the mathematical equations that go with it have been proven correct time and time again to study the different pieces, and they can help you study the physics, the quantum mechanics of the atom. Now, what we're going to be doing is continuing with this section by looking at the controlled experiment. When you have a controlled experiment and you go to create it, one of the things you need is a detailed list of what's going on. That detailed list is called a procedure. You need to have a good procedure, and the procedure has to be written well enough that it can be easily understood and easily followed step by step. Try not to have any confusing wording in there. At times, it can't be helped just based on what's being asked to do. But you want to try to make a procedure when you're creating an experiment that anybody could pick up and follow. If you asked your friend to read it and you don't think they could follow it step by step easily, the same way that you did it, then you probably don't have a complete procedure yet and you need to do some revising. The other thing you're going to need is a list of materials. After you have your procedure, or after you start to make your procedure, when you're trying to figure out what you're actually going to do in your experiment, you need to figure out your variables. Or variables are something that, again, sorry for the typo, something that may change in an experiment. We've already studied the independent variable and dependent variable. The independent variable is the thing that you're controlling in this experiment, and the dependent variable is what's affected. It's what you're trying to see what happens. The other two variables are constants and controls. Constants are the things that you want to keep the same every time you test it. For example, if we go back to the question of what happens when you tip over a cup of water, a constant would be the type of glass, the size of the glass, the amount of water, where you're tipping it over. Are you tipping it over on carpet every time, on a table every time? Those are the different constants that you want to have the same every single time. You don't want anything to affect the experiment other than, in this case, tipping over the glass of water. Your control then is what you're comparing your results to. So in the example with the cup of water, your control would be the cup of water that you don't tip over. Nothing happens to it. You don't do anything to it. That would be your control. You're comparing all your results to it. You're comparing what happens when you tip a glass of water over compared to when you don't tip a glass of water over. Now, we do have an example experiment here. In this experiment, it says every couple of weeks, the teacher has to buy a new goldfish for their class after the earlier one has died. Poor goldfish. The class has come with the idea that the goldfish is not getting the right amount of food when they feed it every other day. They devise an experiment to test this factor alone, holding all other variables constant. So we have our question of basically, how can we make the fish live longer? And they used to feed it every other day, so we have to create a hypothesis from this information. A possible hypothesis that I'm just creating for you right now would be, if the fish is fed every day, then it will live longer. We have an if-then statement. If I do this, then this will happen. If we feed the fish every day, then it will live longer. Your independent variable would be feeding every day. Your dependent variable would be how long the fish lives. It is dependent on how often you feed the fish. So now that we have our hypothesis, we have our independent variable, what we're going to control, and we have our dependent variable, we have to figure out what our control is and what our constants are. The control is going to be real simple. It's going to be the fish that were fed every other day. We know that they were feeding them before every other day, and we want to compare how feeding it every day makes them live compared to the every other day. That would be your control, comparing it to the every other day fish. How long did they live then? Constants there could be a whole bunch of constants. Some examples of some of the constants might be the size of the fishbowl, the type of the goldfish, the temperature of the water, the temperature of the room, the amount of water, the type of food, the amount of food. Again, I apologize for my sloppy handwriting. And these could go on and on. You could say the location of the fishbowl in the room. All of these are constants. These are all things that you want to keep the same every time you test it. Every time that you have a fish there and you're trying to see how long it lives, feeding it every day, you want to keep these things the same. So that way there can never be a question of, well, if I change the food from feeding every day or every other day to feeding every day, but I use two different types of food, well, which one affected it? Feeding it every day or the different type of food? So those are the things that you have to keep constant, you have to think about. You will be getting practice with more experiments, trying to create hypotheses from the experiment, from the data given, identifying variables, the independent, dependent, constants, and control. If you have any questions on these, please feel free to reach out to me. Please feel free to contact me, and I'll try to get back to you as soon as I can. I hope everybody has a wonderful day.